So we're going to talk through what we did here, okay? Remember, we are trying to take the derivative of this part right here. Ooh, goodness gracious. We are trying to take the derivative of this right here, and when we do, in the end, it should look like that. Okay, so all we did yesterday was the first step, and when I look at this first term here, I have to use the product rule. So we took the derivative of the first, the derivative of x is 1, times the second, which is y squared, plus then the first, which is x, times the derivative of the second. The derivative of y squared is 2y, but since it's y, we put dy dx on it, right? Then that makes us done with that first term. So then we move on to this second term here. And we've got the derivative of the first, that negative is stuck to that x cubed, so that's negative 3x squared times the second, which is y, plus the first term, we keep that negative with it, times the derivative of the second. The derivative of y is 1, and we put the dy dx on it. And then we don't forget to take the derivative of the 6, which is just 0. Okay? Everybody with me on that? All right, so now what we need to do, because we're not evaluating it at a number or at a point, is we are going to solve for dy dx. So we can keep the dy dx terms on the left and move everything else over to the right. So the two terms of dy dx are this one and this one. And then I'm going to move the other ones over to the right. So these stay here, and I'm going to get, I don't really need these parentheses here, so I'm going to get rid of those. I'm going to say this is 2xy dy dx. And then this one stays also, so I can say that's minus x cubed dy dx. Right? Then the other two are going to get moved over to the right, so I'm going to subtract y squared, and I'm going to add 3x squared y. Okay? Everybody with me so far? So everything that has dy dx on the left, everything that doesn't on the right, what do we do next? Factor out. Factor out that dy dx. I'm going to factor out dy dx. That leaves me with 2xy minus x cubed, and that's equal to negative y squared plus 3x squared y. Okay, we good? Can I solve for dy dx now? Yes, and divide, so this is going to give me dy dx is equal to, in the numerator I have negative y squared plus 3x squared y. In the denominator I have 2xy minus x cubed. No need to simplify that at all unless you're trying to match it up to a multiple choice question or something. Like, don't even bother if things cancel out. Doesn't matter. Okay? What questions you got? We good? Can do this? Yes? Okay. Let's look at B. Yes? Bless you. Yes. Absolutely. So some options here. Did you get something else? Absolutely. So remember, so that means that you move the dy dx's over to the right probably, which is totally fine. So remember, so here, it's kind of sounded like ours was totally different, but the same exact thing as what this is if I just I change the signs on everything. So this will give me y squared minus 3x squared y over negative 2xy plus x cubed. But I think what he said to me was, do you have the numerator look exactly the same? And then, but then the denominator, you had them switched around, which is fine, right? So it could look exactly like this, or, and if it was multiple choice, they probably would put the positive one first, but x cubed minus this would be the same thing, right? So absolutely. Very good question. Thank you for asking that. We good on that? And the only, again, nobody's trying to trick you. It just depends on how you solve it. It's just what happens, okay? Anything else? All right, so let's look at B. says find all the points on the curve whose x-coordinate is 1 and write an equation for the tangent line for these points. Okay, so when we've been doing tangent lines up until now, we've just had like one tangent line at one point. The way this is worded doesn't imply there could be more. It says find all points on the curve whose x-coordinate is 1 and write an equation for the tangent line for each of these points, right? So if we have an x-coordinate of 1, I need an ordered pair, right? So how do I find my y value? And I substitute it in, exactly. If I want my y-coordinate, do I substitute it into dy dx or the original? The original. The original is going to give me my y-coordinate, right? So let's substitute it into that. Substitute x1 in for x. So this is going to give me 1 times y squared minus 1 cubed times y equals 6. Okay? So really this is just y squared minus y equals 6. So how can I figure out what my y value is? How do I solve this? Do I start taking square roots of things? What kind of equation do I have? It's not a difference of squares, but you're on the right track. You're in the right neighborhood. It is a quadratic. So could I factor it? What do I have to do? Like I have an x squared, right? I don't get to solve it just like y equals 3x minus 7, right? It's not something like that. So if this is a quadratic. Before we start to factor it, we have to do what with it? Before we do that, set it equal to 0. Yeah. So that you're not making it math. Yeah. Y squared minus y equals, no, not equals, because we're setting it equal to 0, sorry. Minus 6 equals 0. Now can you factor it? Oh. Yes, so now we can factor. And this is going to be y and y. The 6 is negative, so the signs are opposite. What's my positive number? 2 and a negative 1. Okay. So we're going to have 2y, what? Negative 3. Oh my God. Negative 3. Yes, thank you. One of these days I'll get through an entire lesson without making a mistake. May not happen anytime soon, but that's my goal. All right, so then I know that y is going to be equal to negative 2 and 3, right? So I have 2 y values, which means I'm going to have 2 points. So I'm going to have to write equations for 2 lines, right? So for each one, I'm going to need a point and the slope. So my point here is my x value is 1. My first y value is negative 2. I'm going to need a slope for that. That slope is going to be dy dx evaluated at 1, negative 2. Right? Then I'm going to have a second one. I'm going to go ahead and write them both down so I don't forget to do them. I'm going to have a second point. And that's going to be 1, what? 3. And then my slope is going to be the derivative evaluated at 1, negative, nope, positive 3 at the point. Okay? Everybody understand where all that's coming from? All right, and we already found dy dx, right? Oh, and the other thing is, oh, I see, because that's probably why you were asking me, because that's what it looked like right there. And so I really should have flipped that around and made it look, but it's the same thing. Those are fine. And it did tell me. So if you have a question like this, right, and you couldn't get it there, then you're not going to get the points for this stuff right here, but that doesn't mean you can't do this because they did give you the answer from the beginning so that you can actually do that. Because if you can't make sense of A, you have no hope on B. But because they give that to you, then you could have used it. So we'll just use the first form that, you can use whatever form you want, but I'm going to use that first form you came up with just because it's there. All right, so if I want to, I need to find this here, so this is going to be equal to, then I have negative y squared, negative 2 squared, plus 3 times 1 squared times negative 2. All over 2 times 1 times negative 2 minus 1 cubed. Right? Just substituted it in. That's all that was. So let's clean that up. We don't want to make mistakes here, even though I might. Negative 2 squared is 4, but then I have to make it negative, so I actually have negative 4, and then 1 squared is just 1, and then that's going to be a minus 6, right? 2 times a negative 2 is a negative 4 minus 1, so I get negative 10 over negative 5. You agree with that? It's equal to 2. Let's see if I agree with myself. Nope, that's not what I got. Of course, I probably did it wrong the first. Oh, shoot. No. Oh, I think I did it right. I did it wrong on here. Do y'all agree with what I have? Yeah, I know what I did on here now. I substituted in a negative 2 here, but negative 2 is my y, not my x, so that doesn't make any sense. So this should be the correct answer. There you go, 2. So sometimes it's good that I don't agree with myself. All right, am I done with the purple part? Why did I find this? To write the equation, right? So now let's go ahead and we can write that equation. So that means I have y equals the slope, which is 2, and I'm using this point right here, times x minus 1, and then minus 2. If you wanted to do y plus 2 equals that and put it in the official, but that's totally fine too. Everybody okay with that? All right, so you finish the rest of this while I finish the rest of this. So let's see if we agree. Maybe I won't agree with myself again. Let's see. Do you not agree with me? You do? Yeah, right here. 1 squared times 3. So that's just 1. So there's just 3 times 3, which gives me 9 right there. Okay. Yeah. All right. So then so that gives me 0. Now, when you go to write the equation of the line, you got a couple of options. If your slope is 0, what does that tell you about your line? What kind of line is it? Horizontal, right? And so you could just write the equation of a horizontal line. That's fine. But if you're afraid you're going to get it mixed up or do something weird, just do it the exact same way you did up there. We've got y equals the slope, which is 0, times x minus 1 plus 3. And you do not have to simplify it. But you see how that really just becomes y equals 3, which is a horizontal line? But you can totally leave it like that. Totally fine. Okay, so it depends on whether or not, if you want to put y equals 3, that's fine. If consistency is better for you, so you just do the exact same thing every time, that's fine too. Okay? What questions you got? Okay, so we're going to do one more that's not on here. So why don't you turn in your ISNs to whatever page this goes on, and you can just write it in the lines. And we're going to find dy dx for cosine of x squared y cubed equals 6. Okay. So, I'm going to give you a second. I want you to at least attempt, and not wait for me, get the first step done. What kind of rules are we going to have to use here? Chain and product. Bless you. And we got some y's in there, so we also have to do the implicit, right? You can just do the first step and stop so that we can make sure that we're all comfortable with that. I'm giving you a chance to reason through it. Got to be careful with your parentheses here too. Okay. Are we ready for us to go through this together? All right. So we're going to start with this term right here on the left-hand side. We're going to have to use the chain rule, so we're going to take the derivative of the outside, which is the trig part, right? What's the derivative of cosine? Negative sine. So that's going to give me negative sine, and I leave the inside alone. X squared y cubed. Okay? The inside of the trig stuff never changes. Then, since we left the inside alone, I need to take the derivative of this, which is going to require the what? Product rule. And the product rule gives us how many terms? 2. Okay? So since the product rule, oh, go ahead. Do you have a question? No, you good? Okay. So since the product rule gives me 2 terms, I got to make sure that I have parentheses here that I'm starting to put my product rule in. Does that make sense to you? So now I'm going to look at this, and I'm going to take the derivative of the first, which is what? 2x times the second, which is y cubed, plus the first, which is x squared, times the derivative of the second, which is what? Squared. Then what? dy dx. Okay. Then I can close those parentheses. But do you see why those parentheses are important there? Okay. And then this is equal to what? 0. Be careful there, bless you. All right, we good? Now, remember one thing that you can look at is before you start, you only have one term that has y in it, right? So when you get your first step, you should have 1 dy dx in there. If we had 2 different terms that had y's, we should have 2 dy dx's in this step. If we don't, something's wrong somewhere, okay? Any questions about this step? All right, so now our goal now is to get dy dx by itself. What do you think we would have to do? Can I subtract something to the other side? What do you think I have to do? Like, and if I divide it, I've got 0 divided by that and it goes away. That's bad. I want to get to the point where I can subtract, like this is being added, like I need to get to the point where I can subtract that to the other side. Yes, this. We can't subtract because it's in the parentheses, exactly. Well, here's the problem. If we divide by this, so 0 divided by that, it would 0 out. We would lose factors and stuff in here. We would lose some solutions, so we don't want to do that, but we have to do this. See, Carolina showed me. What is it? It's not FOIL, but you're on the right track. Distribute. You're distributing. Yeah. So I need to distribute. We had been factoring it out to do that, right? Now we're kind of going, just because of the nature of this problem, we're going to have to factor it back in. Multiply it back in. So now I'm going to multiply these two terms together, and I'm going to put this 2xy cubed in front of the sign just because that's usually kind of the proper way to write it, but I can put the negative here. So negative 2xy cubed times the sign of x squared y cubed. All I did was distribute that first term into the first term, right? Can I combine this xy with this xy at all? No, that's a big no-no because of. Then, so I've done this first part. Now I need to distribute it over here. So that's going to be a negative, and I'm going to put this part first, x squared y, 3y squared. And then I'm going to put the sign. Now, if you didn't put in this exact order, it's not wrong, but kind of like the dy dx usually goes last in a term, and then the variables usually go first. That's kind of the proper order, but really you're multiplying. As long as you keep this part right here stuck together, you can multiply the other stuff in any, and I probably should have put the 3 first, but it's not the end of the world. Okay, we okay with all that? And that's equal to what? 0. Now, can you finish it? Try to finish it. You can do it. The rest is a piece of cake. It just looks icky. You got lots of variables there. Everybody okay with that? Yeah. Now, could we simplify it? I think we can. Do we have to? Then let's not do it. Okay? Because we can, but I don't want you to get in the habit of doing that because it could cause you other problems. Okay? Down the road if you don't do it correctly. All right, what questions you got? Anything? What would we be able to simplify? So in this case right here, because just the way that it worked out, I could actually cancel this out, right? Which I know what you're thinking. Well, then couldn't I just divided it earlier and it had been gone? If you get in the habit of that, that causes you bad problems too with factors and other things. So that's one reason why we didn't do that. Then I could cancel these two with one of those, and I could cancel that. Oh, shoot. I can cancel that with that, right? And then that could leave me with 2y over negative 3. Yeah. Okay. And that's fine. But again, they're not all going to work out that nice. And the reason that those weird things happen is because I sort of made up this question. Oh, yeah. Because I can't solve the wrong thing. Uh-huh. Yes. Yes. Unless, okay, just so that make sure I'm answering the question correctly. If I give you y equals 3x squared plus 4x, okay, and you take the derivative, then because there's a y there, we say that dy dx is equal to 6x plus 4. And we had been doing that, right? And so you're fine with that. But again, the reason it's there is because it has a y. So anytime you were taking the derivative of a y, which is technically what we're doing here, we just didn't really talk about it like that because it would have been more confusing at the beginning. Yes, so then if there was no y's in the right, so it didn't need to. When they're mixed up, and then when you're taking the derivative of the y, that's when you write it. Yes. Okay. All right. Anything else? Okay, good deal. So your assignment, I put an assignment in Delta Math, okay? Because that way it will tell you if you are right or wrong. You can look at a little video. You can, that just because I know that you're not feeling great about this, and get some practice that way, okay? Is that a good thing or a bad thing? Why is it a bad thing? You prefer Delta Math? Caden doesn't want to do anything. Delta Math, not AP Classroom. No, Delta Math. Yeah, Delta Math.